Hurtling down a pitch-black highway at night, you rely on blazing exit signs that contain zero internal power. That visibility is a matter of life and death. Mile for mile, fatal crashes occur 3 times more often in the dark than they do during the day. You can't just coat a piece of aluminum in green paint and expect a driver to read it at 70 miles per hour. Without an outside light source, regular ink is completely swallowed by the darkness. The sun naturally illuminates our surroundings through a process called scattering. When a beam of light hits an uneven surface, like the microscopic roughness of asphalt, the photons shatter in every direction. The energy dissipates, leaving you with a dull, faint return. This blinding intensity is an engineered optical illusion designed to catch and hoard your car's specific light output. If scattering destroys the intensity of your headlights, the most intuitive fix is to make the road sign perfectly smooth. In other words, build a giant mirror. But mirrors obey the physics of specular reflection. The light will bounce off the glass at the exact same angle that it struck the surface. Because you rarely approach a highway sign at a perfect dead-on 90-degree angle, your headlights glance off the mirror and ricochet into the surrounding forest, or worse, straight into the eyes of oncoming traffic. To the driver shining the light, that perfect mirror would appear as a black, unreadable void. The solution requires forcing the light beam to execute a perfect U-turn, sending the photons directly back to the car. Physicists call this retroreflection. Early traffic engineers achieved this brute force U-turn using heavy, marble-sized glass domes known as cat's eyes. They embedded these thick reflectors into painted wood or metal, bouncing the headlights back to the driver through pure mass. By the mid-20th century, manufacturers figured out how to shrink those thick domes into microscopic glass beads. A photon enters the tiny sphere, refracts downward, strikes a mirrored aluminum coating on the back wall, and bends a second time to shoot straight back out, parallel to its entry path. Today, we use something even more efficient: microprismatic cubes. By arranging 3 microscopic mirrored walls into a corner cube shape, light enters the prism, bounces exactly 3 times in a tight geometric triangle, and calculates a flawless 180-degree return. Modern highway signs utilize massive arrays of these microscopic geometric traps, catching the energy from your car and firing it back with laser-like precision. There is only one problem with building a mathematically perfect optical trap. If it works exactly as designed, it will fail the driver completely. A perfect retroreflector returns a beam of light to its absolute source. On a vehicle, that light source is the headlight assembly, mounted low on the front bumper. The human operating the car does not sit on the front bumper. They sit several feet higher up, inside a dark cabin. Engineers call this vertical gap the observation angle. For a person driving a low-riding sedan, that angle is small enough that they might catch some stray light. But for a trucker sitting high up in a commercial cab, the observation angle is massive. A perfect sign would leave them in total darkness. To fix this, optical engineers have to deliberately sabotage their own math. When manufacturing the microprisms, they intentionally warped the interior walls, shifting the structure a fraction of a degree away from a perfect 90-degree angle. These engineered errors prevent the returning light from forming a tight, laser-focused beam. Instead, the imperfect bounces force the light to flare outward, creating a much wider cone of reflectivity. That expanded cone sacrifices a tiny amount of total brightness to guarantee that the returned light washes over the vehicle's entire windshield, illuminating the sign for anyone behind the wheel, no matter how high they sit. The reliable, glowing navigation that guides us safely through the night relies entirely on a geometry that is intentionally broken. Billions of microscopic flaws, manufactured on purpose to make sure you see the light.